All right, so guys, I'm going to make a couple different videos for lesson sheet number 7. These problems tend to be a little bit longer simply because you can't use your trig chart. These are not going to be exact answers, and that's okay. All right, so in the directions, there's a couple things I want to pay attention to. We've got values of x from 0 to 360. So this is a big hint. Folks, you're going to be giving me answers in degrees, not radians. Okay? And then the other piece is going to be round off all values to the nearest tenth if necessary. And it's going to be necessary. I'm just going to say that, okay? So in problem number 1, we have a problem here. Here's the thing. We have both sine squared and we have cosine squared. Can't deal with that right now. So one of these two has to go. It won't matter which one you choose. For no reason, I'm going to go ahead and replace sine squared theta. And I'm going to remind you how to replace it. So sine squared theta plus cosine squared theta was equal to 1. It's one of your Pythagorean identities. So if I resolve this, as I said I was going to replace sine squared, not cosine squared. If I resolve this for sine squared theta, that would be 1 minus cosine squared theta. So this becomes 4 times 1 minus cosine squared theta minus cosine squared theta equals 0. I'm going to clean this up, right? Distribute a little bit. For cosine squared theta minus cosine squared theta equals 0. All right, so these two terms I'm going to combine. So negative 5 cosine squared theta. I'm going to go ahead and move the 4 to the other side of the equation. Divide both sides by negative 5. So cosine squared theta is going to equal a negative divided by a negative. I'm going to just go ahead and make that 4/5. I need to take the square root of both sides, and as soon as I take a square root, immediately I'm writing that plus minus down. Okay, and square root of 4/5. Now, you do not need to simplify that square root of 4/5. Okay, it really won't help. If you did, it's not a big deal. One thing that you should recognize, though, immediately is square root of 4/5 in any form is not on your unit circle. Okay, it's not one of our trig values that we've been used to working with. It's not a root 2 over 2. It's definitely not a root 3 over 2, root 3. None of those. Okay, so what I'm going to do is kind of give myself a little separate equation here, which is just the positive value for cosine. And I want to figure out what theta is equal to. So remember, to get rid of a cosine, you are going to need to do the inverse cosine of 4/5. So this is going to go in your calculator. However, I want you to remind yourself, because we are dealing with answers that are going to be in degrees, make sure your calculator is in degree mode, please. If it's not, you are going to have some serious problems with these that I don't need you to deal with. Okay, I have a calculator sitting next to me right here, so I just found out that theta prime, okay, this is my reference angle, is equal to 26 point, a whole bunch of decimal places. I am going to round off to the nearest tenth, so 26.6 degrees. Okay, that's nice, that's happy. That's not my final answer, okay? So if you guys have been watching my videos, you know I do this pretty much for every single problem, all right? I'm a visual person. I need to see what angles I'm looking for. I need to see what quadrants I'm looking for. So way back here, we had cosine of theta was equal to either a positive or a negative root 4/5. So where is cosine positive? Well, cosine is positive in the first and fourth quadrants. But I also had cosine equal to a negative root 4/5. Where is cosine negative? In the second and third quadrant. I need an angle value from every one of my quadrants. Okay? So what's it going to look like? I'm a visual person, like I said, so I'm going to reference in, right, drawing this little reference angle here of 26.6 degrees. All right, so this is the rotation off of the x-axis. So I'm going to zoom in here. So I'm just looking at this ASTC chart. Second quadrant, I need that same reference angle that's 26.6 degrees off the x-axis. Well, the x-axis is 180 degrees. So if I'm trying to work backwards into quadrant 2, I want you to take that 180 minus the reference angle. Okay, again, my calculator is sitting right next to me. So this is 153.4 degrees. Okay. Then in quadrant number 3, right, little reference angle, again, this angle is pushed off the x-axis 26.6 degrees. So I'm going to take 180 plus 26.6. That adding 26 will rotate it counterclockwise, and so we'll push into quadrant number 3. All right. So 180 plus 26.6 is 206.6 degrees. And we also have an angle in quadrant 4 here. Okay, quadrant 4 here. We are, again, 26.6 degrees off the x-axis. And how am I going to do that? Well, a full rotation would be 360 degrees. If I'm rotating back into quadrant 4, I'm going to take that 360 and subtract the reference, 26.6. So 26.6, there we go, is 333.4 degrees. So I'm going to put this all together. Theta is equal to, in the first quadrant, 26.6 degrees. In the second quadrant, 153.4 degrees. In the third quadrant, 206.6 degrees. And in the fourth quadrant, 333.4 degrees. All 4 of those are valid answers. 2 of them would be when cosine theta was equal to positive root 4 over 5, and 2 of them are when theta was equal to, cosine of theta was equal to negative root 4 over 5. So I'm going to go ahead and close down this video for right now. I will create other videos for other problems on this page. I know these take some time, so wrap your brain around it, all right? And if you have questions or concerns, send me any messages through Remind, through Canvas, or send me direct emails. All right.